Hi guys, so welcome back to the part 2 of generating random data using NumPy and Pandas. Right, initially we have created the number of records, which is 20,000 records for our, random data. We have already created our age, data, salary, height. So now we are going to go to the fourth feature, which is years in job. So that's what we're going to generate. So here's the fourth one, which is years underscore in underscore job. Right. So this is number of years in current job. So that's what it is. So this number of years in current job. So that's what we're going to be doing. So how do we do this? We create a variable years underscore in underscore job. And here, what we will do is we'll use the NumPy random dot randint. So if you look at the documentation, it returns integers from low, which is inclusive, to high. So that's what it's going to do here using a discrete uniform distribution. So what we're going to do is we want to look at job years from 1, which is low, inclusive, 11, which is high, exclusive. So we have 1 to 10 years. And again, the number of records we're looking for is the number of records is 20,000. Right, and that has been created. And yes, we have this. Now the final one that we're going to be looking at is the 5. This is going to be our weight. When we say weight, how much does somebody weigh? So here we are going to be looking at a random float between 50 kg and 90 kg. Again, it's random data. We're just generating that. So here is random floats between 50 to 90 kg. Right. So again, we're going to use, so we're going to call this weight, and we're going to use NumPy's np.uniform random and uniform. That's what we're going to use. Interesting how NumPy has so many methods that you can use to generate numerical distributions. Then we call this uniform. Again, we look at the documentation. These samples are uniformly distributed over half open interval of low and high. Of course, it includes low but excludes high, right? So again, what it means that any value within this given interval is equally likely to be drawn by uniform. So that's what this is. And so we're doing 50, between 50 and 90. So we're going to just put 90. We're fine if maybe 90 is not included. So it's just going to be uniform, and we're going to be using like a uniform distribution for it, and we're going to have 20,000 records. So there's no love lost if we miss out on 90. Then we have this. So I have run this. So now we're going to create the data frame. So create the data frame. Now, so how do we do that? We just put this data frame. We're going to put the data that we have all created, and I'll put this inside a dictionary. And to do this, I'm just going to create a dictionary. And of course, a dictionary is the closest thing to generating data and storing data, or rather closest to storing and retrieving human data. And so, a dictionary has key value pairs. So the first thing I'm going to do here is I'm going to have age, which is going to be the name of the column. And of course, the value is age, right? And of course, we're going to do this for the rest, which is we're going to look at salary. We're going to look at salary. So yes, here we go. So this is all we have here. So we all have in here. So we'll create this dictionary. Now the next we're going to do is we're going to use we're going to call this df, and you know that df is short for data frame, right? And then we're going to use pd, which is our pandas library, and we're going to use the method DataFrame for creating a two-dimensional tabular structure, rows and columns. And then we'll have data inside, which is a dictionary. And so this is the DataFrame. So I run this, and then I can simply say df.head, so you can see the first 5 rows. And look at what we have created. So you see we have our data already: age, salary, height, years, and weight. And you can see the distributions have been made here. Look at how this is. And we can also look at the bottom half of the data. So we say df.tail, so the first 5. And this is what we have here. And you can see that it's up to 20,000, and we can know that it's up to 20,000 when we say df.shape. We're going to use the shape attribute, and you can see that we have 20,000 records with 5 columns. So that is what it's like to generate random data using pandas and the NumPy packages. So you can see, so what this does for you is you can use it to generate data and do some, what I call it, quasi data analysis, and you can test what you can do with it. So this is like sourcing data, from scratch, but it is not real data, but it's generated data. So check this out, watch it over and over again, like it, you know how it is, algorithm, and you learn data science from scratch, one Python object at a time.